Hello, class. You're welcome back. So far, we have been doing one thing, and that is looking for the trig values of special angles. Special angles. For example, 30 degrees, we look for the sine of that. Cosine of 30 degrees, we look for the value of that. Say here, 1/2, here, square root of 3 over 2, and so on. Now, we did that for, 60 degrees, 45 degrees, or their values in radians. We want to talk about the inverse of trigonometric functions. That is, we want to be able to move from ratio back to angle. So what we've been doing so far is we have the angles, we have the angles, we have been getting the ratio, the values. Now, we want to have a situation whereby when we have, let's quickly go back to our unit circle, and we say this is root 3 over 2 and 1 over 2 for maybe pi over 6. And I say, what is the angle such that its sine is, say, 1/2? Then you will be able to tell me it is pi over 6. So rather than telling me the ratio value now, you are telling me the angle. So that is the inverse. We are undoing what we have been doing so far. That is the level we are now. We want to undo what we have been doing up to this point. So note, the inverse trig function undoes what the original trigonometric function does. Simple. As is the case with any other function and its inverse. Okay, now let us visit this. For trig functions, the domain is a measure of angle, right? Remember, let's say here is 0, pi over 2, pi, and so on. And we say here is -1, here is 1, and we say, for example, uh, draw something like this for sine and so on. And also for cosine, we can do the same. So the domain here, we say from -infinity to infinity, and the range from -1 to 1. Now, for its inverse, because we now want to move from ratio to angle. So the domain is actually ratio, and the range is now angle. Okay. Moving on. For example, quickly, if sine of x, if f of x is sine of x, then we would write that the inverse of f is this. Please take note of how we write this. Inverse of that function will be, we write it this way, sine inverse of x, or whatever our angle is. Please, when we have this situation, it is not the same as when we have this. Please do not take the two to mean the same thing. This is a reciprocal function, which is in itself the cosecant of that angle. And this is how we write inverse of sine function. Okay, now let us see how we quickly denote that using example. So since sine of pi over 6 is 1/2, it means that the angle now will be sine inverse of 1/2, remember, the domain of inverse is ratio and the range is angle. Unlike what we had for, say, something like this, sine of pi over 6 is 1/2. So for the trig function itself, the domain is angles and the range is ratio. I hope you can differentiate between the two. Okay, moving on. Um, recall that a special property of a one-to-one function. So let us quickly revisit the concept of one-to-one function. If I have, think about this. If I have this graph, is it a one-to-one function? If I have this graph, is it a one-to-one function? Pause this video and think about that. When do we say a function is one-to-one? Well, it turns out that if you perform horizontal line tests, it must meet that graph in just one place, just like this, just in one place. So you can say this is a one-to-one function, and this is not a one-to-one function. What does it mean that this is not a one-to-one function? That is, a single y value is having multiple inputs, multiple x input. Look at it. Our output here is, let's say, 1. The input is 0. The input is maybe -3. The input is maybe 1 or something. So we are having multiple inputs for a single output. So we say it is not one-to-one. However, here, if we pick a y value here, it is only having one x input. At any point you pick that, there will be only one input for it. So we say it is one-to-one. Now, a special property of a one-to-one function is that for any point you pick in their domain, f of that point, you call it b, then an inverse function will satisfy this. That is, that your output, if you make it to become the input, then the inverse of that will become your original input. Does that make sense? You have f of a equals to b. So if this function is one-to-one, if this function is one-to-one, then you can have that the inverse of b is a. You can move back and forth like that if it is one-to-one function, because the output function is having just one input function. So you can move back and forth like that, and it will still be a function. That is, the inverse will still be a function. Okay, so try, like I said, pause this video. What are one-to-one functions? I talked about that. Give an example of a one-to-one function. I gave you one. The linear function is one-to-one. Can you think about another one? Now, a good question for you to think about before we proceed is, are sine, cosine, and tangent functions one-to-one? Think about it. How is a sine function, or how does a sine function look like? Then if it is cosine, how does it look like? Are they one-to-one? Think about that. Now, you would see that the answer is no, they are not one-to-one. Why? They do not pass horizontal line tests. they do not pass horizontal line test. So meaning that they will not satisfy this if let's say f of x equals to y. That means we will not be able to write f inverse of y equals to x. We will not be able to do that because they are not one-to-one function. However, we need to be able to move from ratio back to angle. Just as we were able to move from angle to ratio, we should be able to move from ratio to angle. Now, the question is, when these guys are not one-to-one function, what can we do? That is the trick we are going to play right now. How do we proceed? What we are going to do is that we are going to restrict the domain of the trig functions so that we can study their inverses. Let us revisit sine and cosine graph. This is sine function, sine graph, and this is a cosine graph. On their own, they are not, what's it called? One-to-one. They are not one-to-one. But let's see. What if I restrict the domain to something like this? If I restrict the domain from negative pi over 2 to pi over 2, then I'm going to have something like this. Look at this, guys. I'm going to have something like this. That is something that behaves this way. Not beautiful as I want. Let's say something like that. Now, the question is this one-to-one? Yes, this is one-to-one now because the function, satisfies the horizontal or passes the horizontal line test. So it is one-to-one. We restrict the domain of sine function to negative pi over 2 to pi over 2. And remember what we have been doing. We are studying. So we want to study the inverse of trig function on this domain. The same thing with cosine function. Let's see. I can restrict it from here to, from here to here, meaning I have something like this, from 0 to pi. So I can restrict that domain from 0 to pi. Again, we can see, is this one-to-one? Yes, this is now one-to-one. It passes horizontal line test on that restricted domain. It passes the horizontal line test. So we can study the inverse of our trig function in that domain. So putting all this together, look at what we have. So this is the restricted domain, restricted domains for sine, restricted domain, restricted domain for here sine and for here cosine. So we have the restricted domain. Now, guys, this is very easy to understand. Like, do not memorize this. The reason we are restricting the domain of sine and cosine is for us to be able to discuss their inverses. Because we cannot study the inverse of these functions on the entire domain of sine because they are not one-to-one on the entire domain. We restrict it to this domain. And for sine, it is negative pi over 2 to pi over 2. And for cosine, it is from 0 to pi. Moving on, for tangent as well, we can do the same so that we can be able to talk about its inverse. This is the original tangent graph. And you see, does not satisfy horizontal line test, does not pass that. So again, we need to restrict. And you would see that that is easy to do itself. Just pick from negative pi over 2 to pi over 2. But mind you, remember, we do not get to that pi or negative pi over 2 and positive pi over 2 for tangent. So I'm going to write the restricted domain as this, negative pi over 2 to pi over 2. Open. I will leave it open, meaning I do not get to the end points. However, for these guys, I will write this as negative pi over 2 to pi over 2. And I will write this as 0 to pi because I can get to the end point. It is only for tangents that we do not or we cannot get to their end point. So I leave it open to show that I am not getting to that end point. I leave it open. So I hope that makes sense. So again, this is the restricted domain for tangents, function. All right. Well, let us quickly study this. Each graph of the inverse trig function is a reflection of the graph of the original function about the line y equals to x. That is, if you draw a line y equals to x, you know the meaning of y equals to x, a straight line that passes through the origin. So the function and its inverse will be the reflection of each other. That is, sine of x will be the reflection of sine inverse of x. The same thing with cosine, the same thing with tangent. That is what I try to show you from these graphs. So you can see this is the graph of cosine, on the restricted domain, and now the reflection across this line y equals to x will be the reflection this way. Okay. The same thing with tangents. We have this. So that is just for your, just for you just to know that something like that exists. Now, bringing all this together, what I've been talking about. So we have for angles in the interval, negative pi over 2 to pi over 2. Now, listen, folks. For angles, I'm dealing with angles in the interval, negative pi over 2 to pi over 2, that is negative 90 degrees. No, that is not what I want. Negative 90 degrees to positive 90 degrees, right? For those angles there, I can say when sine of y equals to x, then I can talk about their inverses. So that means the sine inverse of the ratio now would give me that angle. The same thing with cosine, the same with tangent, except that for cosine, I'm dealing with angles between 0 and pi. And for tangent, I'm dealing with angles between negative pi over 2 and pi over 2. Then, maybe you are thinking, so what happens to other angles? Keep that for now. We devise a means to talk about it. But for now, let me summarize what we've done. Number one, we realize that we cannot talk about the inverses of trig functions on their entire domain. So we restrict the domain. And I will say that on that restricted domain, sine function, cosine function, tangent function have become one-to-one. And now we can talk about their inverses. And we say these are the regions where we define those uh, restrictions. Okay, now let us consider example. Given sine of 5 pi over 12 approximately equals to this, write a relation involving the inverse sine. Well, that is simple. So involving the sine function. So that is sine inverse, guys. Sine inverse. So this becomes my input now for inverse 0.9659 equals to my angle. So this goes this way, this goes to that 5 pi over 12. So let me just do this. So I hope this makes sense to you, how to move from trig function to their inverse. So pause this video and try this. Given cosine of pi over 6 is root 3 over 2, write a relation involving the inverse cosine. Okay, now we want to find the exact value of expressions involving the inverse sine, cosine, and tangent function. Then we go back to our favorite frame, the unit circle. Let's see how that is going to help us in solving some problems. So, example, let me see if I can push this so that I can use it. Okay. Example 2. Example 2. Maybe I should. Yes, I want to put it here. I want it by my side. So, here. Okay. All right. Now, evaluate the following. So let us evaluate this. The first one, sine inverse of 1/2. Now, I'm going to call this, let's call it some number A. It's going to be angle, right? It's going to be angle. We know that because I'm sine inverse of some ratio must give me angle. I don't know, so let's call it A. Well, I can talk about the candidates. Firstly, notice that what I'm trying to say is that sine, that implies that I'm saying sine of some angle A is 1/2. That is what I'm saying, right? How to move now? I move from sine inverse to sine function. I'm saying sine of some angle A is half. What is that angle? I can say, oh, well, because you know it, I can say, well, A is, teacher, A should be, we know it, it should be pi over 6. Then someone might say, wait, that is not the only place where sine is 1/2. Look at this place. Sine is also 1/2 there. Okay. Now, what can we do? Well, I would say candidates. The candidates for A, they are, candidates for A are pi over 6, and the other one, 5 pi over 6. But now, how do we know the one that is the real guy? That takes us back to our restricted domain. Remember that sine inverse is defined on this domain, negative pi over 2 to pi over 2. So we are looking for angles that reside in this restricted domain. Now, this is 30 degrees. This is 150 degrees. I've told you a smart way to do that. Pi over 6 is 30. 30 times 5, 150. However, here is negative 90. Here is 90. So this is the angle in between within that domain. So we'll say that implies that our A is going to be pi over 6. So it turns out that sine inverse of 1/2 equals to pi over 6. I hope that makes sense. Let us move on to another one. B, sine inverse of negative root 2 over 2. Again, I will call this A, and then it implies that I can say I'm looking for sine of some angle whose ratio is negative 2 over 2. And now, if we go back to our unit circle, I can find candidates for A. Candidates for A. What are the candidates for A? Negative A is, sorry, sine of that angle is negative root 2 over 2. Let's see, negative root 2 over 2 for sine, that is the y value. Here is 1, negative root 2 over 2, negative root 2 over 2. Here is another one. So I have it at 5 pi over 4, and I have it at 7 pi over 4. Now, which of these is our guy? Let's see. This is 45 times 5. 45 times 5, 40 times 5, that's 200. So, so we have 5 in 5 places. So that would be 225 degrees. And this is, that is plus 90 now. You have to be smart in your arithmetic. So that is plus 90 because I have 5. So 2 pi over 4, that is 90 plus that. That should be 315, I believe. Now, remember, for sine, I'm looking for sine. For sine, I need to find angles in this domain, negative pi over 2 to pi over 2 inclusive. None of these is going to fall here. So what trick can we play now? Well, let us see. Let us see. Let us see. We are having 315 somewhere here, 315 here, right? Remember that if we move from here to here, now we move clockwise. I'm now using the idea of coterminal angles. So I can claim that sine of negative pi over 4 is going to be negative root 2 over 2. Is that true? Yes. Negative pi over 4. Yeah. It's negative pi over 4. If I move clockwise, that is when I measure negative. Or look at it. I use this. I just say, well, I'm looking for coterminal angles, right? Then I say 315. If I subtract 2 pi from it, that is 360. I'm going to get negative 45 degrees. So that is what I did. That is what I did. If I did the same to this, let's see, 5 pi over 4 minus 2 pi. Let's see what we have. That is, I can say this is 4 over 4. So that would be pi over 4. But then for pi over 4, it is root 2 over 2. It is not negative. So that is why this is my guy. I just need to find a coterminal angle with this guy, and it is negative 45 degrees. So conclusively, I can claim that sine inverse of negative root 2 over 2 is negative pi over 4. Answer. Please try to make sense of this whole idea by yourself. Okay, moving on. Let's move on. The next one is cosine inverse, cosine inverse of, let me write it here. C, cosine inverse of negative, what is that? I think I saw, okay, negative root 3 over 2. Again, let me remind you of something quickly. Look at how the inputs now are ratios for inverse trig function. The inputs are ratios. Okay, now we do have this. Again, I will call it A. We do the same thing. We do the same thing. Let us do the same thing we have been doing. Uh, okay. Now, again, this becomes, I can say this implies that I'm looking for cosine of some angle that I call A, such that the ratio is negative root 3 over 2. That is what it means. Now, if we go back to our dear friend, the unit circle, let us try to do some cleaning up so that we can see very well. Okay, now the question here is, we are looking for some angle such that the cosine of that angle is negative root 3 over 2. Well, let us look for negative root 3 over 2 for cosine. Remember, cosine is x values. So negative root 3 over 2. Oh, we have one here. Let's keep going. We have another one here, right? So that is at 5 pi over 6 and at 7 pi over 6. So we have our candidates. Our candidates for A will be 5 pi over 6 and 7 pi over 6. Let's see which of these candidates will work. Or maybe we have to look for coterminal angle as we did here. None of these two works, so we have to like manipulate further. How do we know the one that will work? We go back to what is the restricted domain for cosine, because that is where we want to find the angle that will work for cosine inverse. So it turns out that the restricted domain, recall, restricted domain of cosine is from 0 to pi. Let's see. 5 pi over 6, that is 5/30s. So meaning we have 150 degrees here, 150 degrees. And this is 7/30s. So that is 210 degrees. And it turns out that 150 is within this domain. So we're done. It implies that A is 5 pi over 6. So meaning that cosine inverse of negative root 3 over 2 is 5 pi over 6. Done. Okay. And lastly, let's see. Lastly, I will call it D. We want to look for tangent inverse of 1. Tangent inverse of 1. Again, I will call this guy A. You can call it anything. It doesn't matter. So which implies that I am looking for the tangent of some angle. I call it A. And the ratio is 1. That is what I'm looking for. And if we go to unit circle, we do not have tangents directly on the unit circle. However, we can smartly talk about tangent because tangent is sine divided by cosine. And you know that if we divide sine by cosine here, it is going to be 1. So that is pi over 4. The same thing, if we do it here, negative, we cancel negative out and we have positive 1. Again, 5 pi over 4. So we have our candidates. We have our candidates. So our candidates for the angle A will be pi over 4 and 5 pi over 4. Now, which one is our guy? Recall the restricted domain. The restricted domain for tangents is, do you remember? Negative pi over 2 to pi over 2. Open. You know why it is open. You should know that as a consumer of mathematics, you should know that why it is open. And here I used closed, right? Here I use closed. You should know why here is open. I talked about it earlier. That implies that our guy we are looking for, this is 45, and this is 225, which is outside. So not this guy, it is this guy. So our candidate that wins this election is pi over 4. Therefore, we can say that tangent inverse of 1 is pi over 4. Answer. So I hope this makes sense to you folks. If it doesn't, try to go back in this video and start from where I started talking about the restricted domain, why we have to do that, and how we got it. But I think it should be straightforward. Okay, now you need to pause this video and evaluate each of the following inverse trigonometric functions. Make sure you show all your work the way I did here, neatly. So do that. Okay. Now, I will say welcome back. I believe you paused your video and you worked on all these guys and you use your restricted domain to find the angles, and you understand that these inside guys are ratios and the answer you must get should be angles. Okay, now using a calculator to evaluate inverse trigonometric functions. Well, but teacher, you said we do not use calculator in this class. Yes, but that does not stop us from talking about what we can use calculator to do. Okay, most scientific calculators and calculator emulating applications have specific keys or buttons for the inverse sine, cosine, and tangent functions. This may be labeled, for example, maybe on your calculator you have seen something like this, or arcsine, or a sine, they all mean the same thing. They mean inverse of trig functions. So, evaluate sine inverse of 0.97. This all depends on whatever calculator you are using. But you should be able to get this. Make sure your calculator is in radian because this value is in, I mean, this is a ratio. Actually, this is ratio. So you can put your calculator in radian. If you put it in radian, your answer here will be in radian. If you put it in degrees, your answer here will be in degrees. But I'm going to be talking in radians. So let me just put my calculator in radians. Then I do sine inverse. Sometimes you need to look for second function. Yes, like what I have here, sine inverse. So you can see my the calculator on my phone is using this style, a sine. It's using this, yeah, which is the same thing. So I will put 0.97. So just like this, 0.97, and then the answer is, and look at my calculator, it's in radian. So, and my answer is 1.325. So let me just say 1.33. So if I do the same thing, sine inverse 0.97, I want to do it in degrees. So I just need to take my calculator to degrees, do the same thing, sine inverse of 0.97. Like this. My calculator is in degrees now, and it is 75.9 degrees. So in degrees, in radians. Okay, so that is how to use calculator. So please go ahead, pause, and use your calculator to evaluate this as well. That's another try. Applying the inverse cosine to a right triangle. Now let us make use of our new knowledge in solving real world problems. Let me move this sideways. Okay. Now, look at these guys. Solve the triangle below for the angle theta. From what we have been doing up to this point, we've only been looking for the ratio, the side, the length of the height of the tree, the horizontal distance, all those things. We've never talked about finding the angle, maybe angle of elevation or angle of depression. So now we are free to do that because we have talked about inverses, which is the only way we can get back to angles. And the beautiful thing is everything we've learned in the past is still very useful. So we are looking for this angle now, angle theta. Remember, this is opposites, this is hypotenuse, and this is adjacent. Since I have this length, let me just consider adjacent and hypotenuse. And if I return to SOHCAHTOA, the one that has that is cosine. So meaning I can write cosine of angle theta is adjacent over hypotenuse. That is cosine of theta, which is what I'm looking for, is adjacent is 9 divided by hypotenuse 12. So meaning cosine of theta is, I can reduce that is 3 over 4, right? 3 over 4. Now, what do I do now, guys? I'm looking for theta. Does that mean I can say theta is cosine inverse of 3 over 4? Yes. That is how I can move from cosine to cosine inverse, right? So now our angle is cosine inverse of, I believe this is 0.75, I believe. So now we go back to our calculator and we do, let me be sure. I want my answer to be in radian. So I will take it to radian. Uh, so cosine inverse of 0.75. So that is points. So my answer is 0.72. Let me just put approximately because I still have some values. Or let me do it in degrees. That is cosine inverse of 0.75. So that is 41.4 degrees. So I have that. Now, guys, look at the beauty. We can now move from ratio to angle, just as we have been able to move from angles to ratio. The only thing is we just introduced a newer concept today that allows us to do that. Okay, so using this idea again, pause this video and solve for angle theta in this problem. Further examples, let's see. Trigonometric, sorry. I have this triangle. No, triangle is not drawn to scale. Okay, yes, that's fine. Suppose A is 6, that is, this length is 6, and angle A is 49 degrees. This is 49 degrees. Find length B, find length C, and find angle B. Let's do that. Let's do that. We have everything to do that now. For B, well, this is adjacent. We know this length. This is opposite. Then you know what from SOHCAHTOA. How do I know that SOHCAHTOA will help me? Well, I'm dealing with right triangles, so SOHCAHTOA will definitely help me. So now, to calculate B, opposite, adjacent, that is tangent. So tangent of some angle 49 degrees is opposite, which is 6 over adjacent, which is B. So here I cross multiply. It turns out that B equals to 6 divided by tangent of 49 degrees. And that is 6 divided by what is tangent of 49 degrees is not a special angle. So we will need calculator for something like this. Teacher, wait. Now we are talking about calculators. What am I going to do? If I'm doing my homework and I have something like this, yes, you can use calculator. What am I going to do if we are doing exam and I have something like this? Your teacher is a nice person, you know. I will give you the value of tangent of 49 degrees in that situation for you to use. So in this case, let me take it. So I have degrees there, so I need to work in degrees. So um, tangents of 49. So that is 1.1503. Now, on exam, whereby you do not have calculator, if you leave your answer this way, it is fine. Suppose I've given you tangent of 49 is 1.150. You only need to substitute it here and you leave it that way because you do not have calculator to do that, right? So, although you can still, you know, be smart, like what can you do to get an approximate answer, but it does not worth your time. It doesn't worth your time. So approximately that length is 5.22. Okay. Now we have this length. We are looking for C. Now, we now have too many ways to find C. Remember, we have this length. We have this length now that we just calculated here. We can use Pythagoras theorem to find the hypotenuse. Or if we want to use the SOHCAHTOA we have been using, it is still fine. So this is hypotenuse, opposites. So that is sine of 49 degrees equals to opposite, which is 6, over hypotenuse, which is C. So again, we cross multiply and say C is 6 divided by sine of 49 degrees. So which is, I will just do everything together there. 6 divided by sine of 49. So the length I'm getting is approximately equals to 7.95. So that is C. And finally, the angle B. Where's angle B? This angle B. Let me clean this a little bit for us to see. Okay, we are looking for this angle. We find this to be 5.22. We know this is 6. We know this is 7.95. We have too many ways to find B now. So, we can say this is the adjacent to B, right? And the angle we have, we do not even need to worry ourselves by using SOHCAHTOA in this sense, because look at it, guys. We were given here to be 49 degrees. We were given here to be 49 degrees. We know here is 90, so we can just find B. So our B is, can do 180 degrees because the sum will be that, minus 90 degrees plus 49 degrees. So whatever that is our B. So that is that. And now we can find, go back to our angle of elevation and depression, and compute height of a tree, compute angle of elevation, angle of depression, and so on, because now we know how to do that. So guys, I'm going to be ending this video here. Next time, we are going to be looking at how to evaluate compositions of this form. So till then, I hope you enjoyed this video, and do not forget to do all the tries. We have 1, 2, 3. How many do we have? 3, 4. 4. I believe we have just 4 try it there. So I'm hoping to receiving your try it in class. So till then, have fun, guys, and see you in class. Bye bye.